Okay, continuing on with our world about similar triangles. If I begin with a right triangle, and then I split it up and I take it to a papa bear, mama bear, and baby bear, what I'm going to discover is that I produce three triangles that are all similar because they're going to share two angles, right? Papa bear and mama bear share this angle, and papa bear and baby bear share this angle, and they've all got right angles. So by angle similarity, they're all similar, which means triangle A, B, D, excuse me, let's make that ABC. Triangle ABC is similar to what other triangle? What did you just say? ABD. So we go along the hypotenuse first. ADB and BDC. It's hard to keep track of those. And then that's what we're doing here is we're saying, okay, what if I break this up into three triangles? Here's my papa bear. Here's my mama bear. Here's my baby bear. I'm going to align these triangles all facing the same direction. And let's label them. How do I label this one? What goes up here? Papa bear. That looks like a 90-degree rotation clockwise. P, Q, R. What about mama bear? Well, the right angle is S, isn't it? And the short side goes to Q. Tall side goes to P. Baby bear, what's the right angle? S. And the tall side goes up to, and the short side goes out to R. Okay, so that shows us how the corresponding parts match. And once we understand which pieces align and match, we can then create proportions. So for example, here's a scenario. We're looking for X. I want to solve this by writing a proportion. And remember that anytime I write a proportion, I have to ensure that this top row has something in common. And this bottom row has something in common. And this column has something in common. And this column has something in common. So we know we're solving for X. So I'm going to put X right here. How would you describe X? Okay, I could call it the altitude of the big triangle. Unfortunately, I don't have the altitude of the small or the medium. You see the one that I've highlighted? That's like the medium triangle, right? I shaded. Do you agree that's the medium triangle? And it's the small side of the medium triangle. So this cell is the medium triangle, the small side. That means right here, I need the small side of one of the other triangles. 9, that's the small side of the big triangle. I like that. That means this is what? If this is the medium triangle, this is the large triangle, right? Now I've used up the small side. I need to be able to find a different side. In my medium triangle, I've only got one other side, this one. So if this is 12, because it's my medium triangle's what side? Hypotenuse. Then this cell should be what number? Because it should be the hypotenuse of the large triangle. This is a valid proportion for this picture. I can cross multiply and solve. 8/15. And I should reduce that as best I can, either as a precise decimal, not rounded, or a fraction simplified, or a simplified radical. So 7.2 would be fine. If I multiply that by 5, I would get 35, and one more is 36 over 5. One of those two answers would be fine. How's that feel? 5, that works perfectly in my brain. 3, when you describe it as carefully as you did, I see how it works, but I don't think I can do that. 1, it doesn't make any sense to me. Okay. Lower scores. That's what I would expect right now. We're working towards this. Okay, what about this next one? We know that we want the X in there, right? So I'm going to put the X here. It doesn't have to be here. Should we put it somewhere else? No, you want it here? Okay. How would you describe X in terms of triangles and sides? Short side, medium triangle. That means this thing has to be medium triangle, something other than the short side. And what does this have to be? Short side of another. I like what you said, 11.2, because that's the short side of which triangle? The large one, right? So now we've got medium triangle and large triangle. We got to pick another side. Here's my medium triangle. I've only got one other side. Okay, so that's my medium triangle. I'm going to put 21. And what side is that? Hypotenuse, which means down here, it's got to be the hypotenuse of the large triangle. Okay, and then you guys solve that with cross multiplication. I'll leave you this one to do as well. This is hard. I'm telling you, doing it this way is like muscling it out. You'll see later in this packet, there's an easier way to do it, I think. All right, and geometric mean, if we say that X is the geometric mean of A and B, this is the way I think of it, but it could be expressed as X squared equals A times B, or the ratio that we created. These are 3 different ways of seeing a relationship that is geometric mean. So let's say I want to find the geometric mean of 6 and 30. I would write X is equal to what? Square root of 6 times 30. And I would simplify this radical. 6 times 6 times 5. X is equal to 6 root 5. That's my answer. Yeah. Would you please do number 6? Go. Because 30 is 6 times 5. It could be. And if I did that, I'd get the 3's to pair up and the 2's to pair up, which would give me that 6. I just pulled out a bigger number to save myself some time. Second.
Yeah. I guess. So for this one, I just did like 6 and 2 and then 2 and 25 and saw that there's 2 2. So is that like right or no?
It's not fully simplified because 25 is also 5 times 5.
Okay, so I could do 7 here then?
No, if they get multiplied, it'd be 10. 10 root 6.
Okay.
And then what did you do here?
Oh, that one. I just tried to do this, and I know it's definitely wrong. So I'm gonna say
It's not wrong, but it's an
well, yeah, but it's yeah.
It's not a simple radical. Okay, folks, give me just one more minute. It'll take about 2 more minutes, actually, and then you'll have the whole period. Please flip to page 2. Okay, Kiki and Georgia, guys, focus here. Page 2, please. As I said, this packet is designed to teach you discrete theorems rather than the color system I taught you. So what this says is the geometric altitude mean theorem says that this altitude, BD, is equal to the geometric mean between what 2 sides? Think of the puddles. Good. AD and DC, right? This puddle goes up there, so does this puddle. So if I wanted to find the value of x here, I'd say that x is equal to the square root of what? 8 times 12. 4 times 2 times 4 times 3. These are bigger numbers. They could go more. But if I take those out, what's left are prime numbers. So 4 root 6 is the simplified radical answer. And it's not a bad idea to also give me the decimal equivalent. Just get used to doing this in your calculator because there are times when you need that. Doing that in one of these calculators usually means 4 times, and you have to get the square root symbol, which is here in blue. So that means activate the second features and then do x squared. 9.7979, so that rounds to 9.80, round to the nearest hundredth. And I'm putting the squiggly sign there because that's approximate. I'm making a rounded effort on that. It's not precise, whereas this is precise. This next piece is the geometric mean leg theorem. So let's say I were looking for AB. Which 2 puddles go to that? Very good. AD and AC. Or if I went to the other side, BC is which 2 puddles? DC and AC. Good. So if I want to do number 12 here, I'd say X is the geometric mean between which 2 sides? What 2 lengths? Good. (24) is 4 times 6. 6 is 3 times 2. 26 is 2 times 13. 4 can go further. 2 times 2 times 3 times 2 times 2 times 13. 2's pair up. 2 times 2 is 4. They're on the outside. 3 times 13 is root 39, which is approximately equal to 24.9799.98. Expressing it as a precise simplified radical and a decimal rounded to the nearest 100th. And this might be a good place for you to consider drawing the image we had on the board. I don't know if you have colors available like we had. And you remember that poor guy from the Macy's interview? I did not. They were saying that there's a puddle of yellow paint all the way along the bottom there. There is a puddle of blue paint right along here. There's a puddle of red paint right along here. And when these things begin to wick up, whatever color is at the bottom, what color comes up the right side here? Orange, because that's the combination of red and yellow. What color comes up that middle? Purple, because it's blue and red. And what color comes up this side with blue and yellow? Green. And then I would suggest that we also do a version down here that has the letters A, B, C, H, X, Y. And again, it's all about the ties hanging from around the neck. So B is the geometric mean between what two parts? Y and C. A is the geometric mean between what two parts? Good. X and C. And H is the geometric mean between what two parts? Y and X. All right, the rest of this packet has applications of this for you to solve for various variables using these ideas. Enjoy your 3-day weekend. We'll see you on Wednesday.